So when you are doing a worked example in physics, or when you're doing any question in physics, there are a couple of things I recommend you do. The first thing, when you have something like this, the words can be tricky to follow, they can be confusing sometimes. I would suggest you draw a diagram. Okay, that should be the first thing you do. The second thing you do after you've drawn a diagram is put in all of the information that you know. So let's have a look at this. A toddler drags his 4.5 kilogram cart of blocks across a floor at a constant speed of 0.75 meters per second. The force of friction between the cart and the floor is 5 newtons, and it is being pulled by a handle which is at an angle of 35 degrees above the horizontal. So let's draw this. So I haven't given you much room to draw, I'm afraid, but there's our cart. Here's our toddler. When I say draw, my artwork is not great, so don't worry too much about yours. So there's our diagram. We know that that angle in there is 35 degrees. And we know that it is a constant speed of 0.75 meters per second. And we know that there is a frictional force between the cart and the floor of 5 newtons. So friction always opposes motion. Okay, so the friction will be pulling against the direction of motion. All right, so there's our diagram. Now we're ready to tackle these questions. Calculate the net force on the cart. Now before we go any further, is everyone familiar with net force? No, not a lot of emphatic yeses. So net force is basically all of the forces added together. All right, that's what we mean by net force, and we'll be coming to that a lot. So this is actually a really, it's quite a clever worked example because we've just recapped Newton's 3 laws. Each problem here is one of those Newton's 3 laws. Okay? So first thing, what do we know about the motion of our cart? It's constant. If it is constant from Newton's first law, there is no net force acting on it. Okay? It will continue what it is doing. If it is traveling at a constant velocity, then all the forces on it are 0. The forces are balanced. So our net force, all of our forces added together, net force, are equal to 0. Okay? There is all the forces acting on it cancel each other out if it is traveling at a constant velocity. Okay. Next. Calculate the force that the toddler exerts on the cart. Okay, so we know that the net force is 0. All of our forces added together are 0. But if the toddler is just standing and not exerting a force on the cart, it's not going to move. All right, so the toddler must be exerting a force on the cart. So we need to work out what that is. So a couple of things we need to be aware of. If we just look at the horizontal forces acting on our cart, okay, there's our cart. We know that there are 5 newtons acting backwards. Okay, 5 newtons of friction. But we also know the cart is traveling at a constant speed. So therefore, what must be the force pulling it forwards? 5 newtons. Okay, so there must be 5 newtons pulling it forwards as well as 5 newtons pulling it back. However, it is not quite that simple, because the toddler is not pulling horizontally. The toddler's pulling at an angle. Okay? So, the toddler is pulling at a 35-degree angle. So we want to work out what the magnitude of that force is along the handle. Okay? That is the force the toddler is applying. The way we do this is through trigonometry. Okay? So we know that the horizontal force there has got to be equal to 5. So I'll draw this a bit bigger. We know that our horizontal force is 5 newtons, and we know that that is 35 degrees. So therefore, the force that the toddler is pulling with is just the hypotenuse of our triangle. Okay? So from trigonometry, we've got our adjacent side. We want our hypotenuse, so we're using cos. Might need to drop down a little bit here. So the cos of 35 is equal to the adjacent on the hypotenuse. So if we rearrange that, multiply both sides by h, divide both by cos 35, we will get h is equal to 5 on cos 35, which should be, I don't have my calculator handy, here it is, should be 6.1, I think. Yep, good. So our toddler is applying a force of 6.1 newtons, okay, because the toddler's pulling up at an angle, he or she needs to apply more force than if they were just pulling horizontally. So in order to get that 5 newtons of horizontal force, they need to apply 6.1 newtons at that angle. And that will give them the 5 newtons of the horizontal force. Okay. The last bit. Determine the force that the cart exerts on the toddler. All right. This is pretty straightforward. This is Newton's third law. If the toddler is exerting a force of 6.1 newtons on the cart, then the cart must be exerting a force of 6.1 newtons on the toddler. Okay? For every force, or for every action, there is an equal and opposite reaction. For every force, there's an equal and opposite force. So the tricky bit there is part B. All right, working out that when a force is applied at an angle, we need to work out, you know, what the force we need to balance that whole thing out is, and then, using trigonometry, what the total force to give us that horizontal force is going to be. All right. Any questions there? All right. The next one, I'll get you to try yourself, please.